thermal fluid sciences experts. This is Pro-Ready Engineer.
Well, hello again. This is Bassam Abdelnabi from Pro-Ready Engineer. This is a much shorter video from the very long 2 hours video that I typically post. So if you like it, make sure to like and subscribe, and just consider watching the full video. Thank you and take care. So what's Bernoulli equation? It's the energy equation applied on a moving fluid with some assumptions. Take a look here. Here's a moving fluid. And I pick a station, this is 1 and this is just 2, any 2 stations. And at 1, let's assume there is a V1, there is a Z1, there is a, right? And at 2, there is a V2, there is a Z2. And let's assume there are no losses. This is an assumption, I'm assuming there's no losses. And let's assume, as we have done a second ago, there's no power extraction, power addition, heat generation, none of that. Write down the energy equation now. And assume that this is incompressible. You remember what happens if we assume incompressible? You say H plus V1 squared over 2 plus GZ is equals to H, but H is U plus P over rho, but U is CV times T, but temperature didn't change, take that out. Now with pressure, I can write it down instead of enthalpy as pressure. You arrive down here. Bernoulli equation is where you make all those assumptions I said to write it down this way. Instead of saying enthalpy, the kinetic energy plus potential energy is constant, this just means they are constant. Energy has to be constant. Where it go? Instead of saying enthalpy, you use pressure. Why? Because this is an incompressible. So you can use pressure instead of enthalpy. And you say the sum of 3 is constant. Let's simplify it more to arrive at a very powerful concept. Let's say that the Z did not change much. Elevation is not much different. Take the G delta Z out. Here's what it looks like. Now, this is very powerful. Right there is very powerful. It says that when a fluid is moving, pressure and velocity, energies, their sum is the same. Pressure energy, P over rho, plus kinetic energy. Their sum is constant. If the velocity goes up, pressure comes down. If the velocity goes down, pressure comes up. Extremely powerful. Let me tell you, today I spoke about nozzles and diffusers, and I told you at the time, bear with me. It's easy for you to understand that when the nozzle comes down in cross-section, see, m dot is rho AV. As the area comes down, V comes up. Straightforward. Diffuser, area comes up, velocity comes down. Straightforward. But I told you then, a diffuser increases pressure. A nozzle decreases pressure. I told you, bear with me until I talk to you about the energy equation, and now you know why. Now you know why. Why? Because the pressure, energy, and kinetic energy summation is constant. If the velocity, one more time, if the velocity in a nozzle comes up, pressure comes down. The sum has to be constant. It's almost as if you are saying, listen to this very carefully, velocity is coming up on the expense of pressure. Pressure is paying for velocity to come up. A diffuser, velocity is coming down, and it's giving you high pressure now. Pressure is coming up on the expense of velocity. The velocity is paying for it, so the pressure goes up. And now you know how the diffuser and the nozzle works. You see this diffuser or nozzle. Is it a reasonable assumption when you look at the firefighter nozzle tip. To say that the losses there is ignored, absolutely. Absolutely. When we spoke about the pressure losses in pipelines, we started talking about, like, long tubes and, long pipes and things of this nature. Well, this nozzle losses, frictional losses, compared to the kinetic energy level is negligible. How about if I want to incorporate it for any reason in the world? Like, I want to be very accurate and I want to apply this equation to that nozzle of the firefighter, and I will say P1 over rho plus V1 squared over 2 is equals to P2 over rho plus V2 squared over 2 plus the losses on the way. And I will estimate the losses and I'll put it in and I will get the V2 that is accurate. I'll bring the actual velocity coming out from this nozzle to be accurate. Try that exercise. To your surprise, you'll find out that ignoring it made you 99% correct. The best engineers I've worked with, and this is what I want you to be, even if you are a 60 years old professional engineer, it's not too late. The best engineers I worked with can very quickly do order of magnitude analysis. All right, this is very big, this is very small. It's like when you say, all right, I'm asking, how much money did you make this month? So you say, I made, $10,000. Well, you didn't tell me it was $10,000 and, 3.5 cents. Because you immediately were calibrated. What does it matter? What is 3.5 cents? It is $10,000. We don't talk this way. Now, likewise, there is a way in engineering that you talk that shows that you are unbelievably powerful in understanding the concepts, what to add and what not. The difference, listen very carefully to this, between the one who will use this equation to get the velocity at the exit of the nozzle. You will ask the person, give me the velocity at the exit of the nozzle. He goes on the 2 minutes. Here's the velocity. Then there's the other person who does not have a good understanding of engineering concept. He is a person who is not taught well. You tell him, give me the estimate. You say, okay, give me a couple hours. I need to be accurate. So the first person you give the task to, he took 2 minutes. All right, boom, here's the number. Thank you. The other person, he said, give me a couple hours. He went there for truly a couple hours. And he comes back after, 3 hours. Yep, I solved it. You tell him what was the velocity. He tells you the velocity was 222.365 feet per second. The first person told you the velocity is 232 feet per second. Which one will you work with? The one that said 232 all day. I do not want to work with the other one. You are wasting my time. You are wasting my resources. If you are an employee in a corporate, you are wasting the corporate money, resources, and time. You are an engineer. Engineers do order of magnitude analysis. They know what to include, what not to include. Very good.